cosmos.
It's a very cool and expensive eye that can look at very, very small distances, like about a billionth of a meter.
We designed this machine so that wherever the Higgs boson would be, we would be able to find it.
Flushing the Higgs out of hiding begins in a modest little red bottle full of hydrogen atoms, the smallest and most abundant element in the universe.
All the protons that we use at CERN are taken from a bottle that size. They start their journey here, and they continue down this orange line, and that is the linear accelerator.
Trillions of hydrogen atoms stripped of their electrons are injected into the collider.
Every 1.2 seconds, 10 to the power 14 protons are being accelerated down that line.
The protons accelerate around larger and larger loops until they are finally directed into the main ring. To keep the increasingly energetic particles confined, the LHC relies on immensely powerful magnetic fields generated by 1,232 primary superconducting magnets, cooled to just a few degrees above absolute zero by 120 tons of liquid helium. After about 20 minutes of acceleration, each bunch of protons is moving at nearly the speed of light, with as much energy as an onrushing locomotive. Finally, the protons are carefully steered into violent head-on collisions, converting the huge energy into showers of exotic, energetic particles scattering in all directions, many decaying into showers of even more particles, setting the stage for the hard work of detecting the Higgs.
Trying to figure out what happens in the collision of two protons at very high energy is like analyzing what happens in the high-speed collision of two garbage trucks. Garbage is spread all over everything, and most of it is garbage in the sense that it's not interesting. It's old stuff that we already knew about. And in all this garbage that's spraying out in all directions on the highway, you have to find the golden needle, the rare artifact that you're looking for, the Higgs boson, something entirely new.
To the scientists at CERN, a collection of physicists from all over the world, the stuff produced in these powerful collisions is anything but garbage. Each particle has a well-understood identity, described with great precision in one of the most accurate theories ever devised to explain the workings of the universe. It's called the Standard Model, and one of its key contributors is Frank Wilczek.
Hi, welcome. A lot of what I do is really just play. I mean, I play with the equations, ideas.
All that playing won Frank a Nobel Prize for his contribution to the Standard Model.
Well, what do we got here? Looks like an instrument of torture for the model.
The Standard Model is essentially an understanding of how all the known pieces of the universe fit together, except for the mechanism of gravity, creating a mind-boggling tapestry.
This is going to be a hell of a puzzle to figure out. All right, now, promising start. We think the Standard Model contains all you need in principle to describe how molecules behave, all of chemistry, how stars work, all of astrophysics. Not only how things behave, but what can exist. These are the rules of the game.